we'll get started. I'm Linda Miller. I was involved in the marking process, and this is Dan, who was also involved in the marking process. So we've got our version of solutions that students could have done. Obviously, students come up with a whole range of other solutions, some of them right, some of them not right. So this is just one example of what the solutions might be like. My aim will be to talk to what we're encouraging students to do when they write their answers and the sorts of common errors they're making, so to warn them, don't do this. Now, one thing that you haven't got, which I would have liked you to have, was a copy of the subject assessment advice, but that is on SACE, on the website. I totally encourage you to copy that, print that off and have a read of it. A lot of what I'm saying tonight is sort of a meld of our solutions plus information that's on this assessment advice, but it also includes things about things to watch out for in your folios or setting your SATs. So just to start with, I wanted to address a couple of key things about the exam that the Chief Examiner has prepared this report for us. We no longer mark crossed out work. Back in the day, students could do 2 solutions and cross one out, or have 2 solutions without one crossed out, and we would mark them both and we'd give them the best mark out of the 2, -1 for not having made a choice. So they could never get full marks, but they could get as much as we could find for them. Now they need to clearly indicate which has to be marked. If they cross something out and come back and go, oh no, now that I'm not panicking, I want that marked, they need to circle it and say, please mark this one and cross the other one out. They've got to make it really clear. So get them to practice that when they're doing tests for you. So obviously scribbling stuff out means that if they change their mind, we're not going to be able to read it. So just a neat cross through work that they don't want in case they come back and think that was the key. Let markers know if they're going to need to use an extra page. Same sort of thing will happen in your tests. You might have a blank page at the back, so get them in the habit of saying, see back page, or see page 8. And when they get to that, to put 4D. It just means the marker is not going to miss marking that extra work that they've done. It would be very rare for a marker to overlook that, but it just, we want to cover all the bases. We don't want them to miss marks because they happen to squeeze something on an odd page that didn't get checked. Obviously, we're always trying to get them to make sense of their answer in the context of the problem. If they make a silly mistake, we don't tend to penalise that unless it really simplifies their following or working and they can't show us the knowledge, skills and understanding that question was actually trying to assess. So we try and give follow-through marks as much as possible. So one silly little, I wrote a 2 + 3 is 6 when it should have been 2 + 3 is 5. We'll try and just work with that, not penalise them. If they start making multiple errors within the same question, then they'll start losing marks. Yep.
I'm actually new to SACE this year. So basically, if a kid accidentally writes a +1 instead of a -1, you don't just mark down once and then do a carried mistake, or do you just leave it?
You'd have to have a look at the question. If the +1 versus the -1, you were not sure that they actually understood what was going on. But if they put +2 in this row and then they had +3 in the next row, a silly like copying error, that's clearly not a lack of understanding of a mathematical process. So you can be a bit forgiving. Also, in the exam, we mark in whole marks. In tests, you can mark in whole marks if you like, but you're also welcome to mark a half mark. So sometimes I'll ping kids a bit rougher than might happen in an exam because I'm trying to train them to do the right thing. Can I just have a show of hands? Who is new to teaching methods this year? Cool. So yeah, a number of people are back for a few times. You're already familiar. You're just trying to get the icing on the cake about what's going on. The first time you come to one of these sessions, I remember I came, oh wow, there was so much to take in, but it was really useful. But I found I came back 2 or 3 years in a row after that. I was still learning a lot each time I came back. You just can't take it all in. But these sessions, I think, are very valuable for your understanding where you should be pushing your kids as you go through the year. It's all, a lot of this is written in here, so keep having that assessment advice near you and you ask other people who are teaching as well if you've got a contact. Obviously, pay close attention to the wording of questions. We always want them to do that. We always want them to get used to read a question and then go back and reread it once you've answered it to see if you missed finding something. But words like exact, using an algebraic process, those sorts of things imply, and you'll tend to find that there's a big gap for them to do it, and there's 3 or 4 marks on offer. That's telling them you've got to show us working steps, you've got to show us some algebraic ways of getting this. It's not just put it in your calculator. If it's a 1-mark question and there's only 3 lines to write it on, there's your hint that you should be using your graphic calculator. Discerning use of technology is one of the things that we're meant to assess, but we are giving them those sorts of hints about when to use the calculator and when not. So hence, exact solutions and showing algebraic working are your hint. The hence, train your kids to read that as, so you must be using something from the previous section in the next section. You can't just suddenly come up with a different way of doing it. You might earn a few of the marks, but to get full marks, you have to be applying the previous bit at that hence means. I think I've covered the next point. We take a lot of trouble. Sometimes I've been involved in helping to write some questions and exams, and there's a lot of trouble taken to make sure that if kids can't do the first part, they've got a way to get back into the question further on. So you'll see quite a few questions that show that the first derivative is blah. So that even if they couldn't work out how to do that, they can use that first derivative to then say, oh, where's a stationary point or whatever. So train your kids to keep looking for ways to get back into a question even if they're not sure how to do earlier bits. And that they can use the information given in the earlier bits to help them with the later bits. That seemed to work quite well last year. Lots of students seemed to go the whole way through the paper. They might not have got everything right, but they were actually having a go at everything even if they couldn't get earlier parts. So it's good. Rounding. This will sort of get covered as we go through. So if I say it now, it might save some time as we're going through individual questions. We expect students to answer to 3 significant figures, or as appropriate. So obviously if the answers are integer, they're integer. But otherwise, 3 significant figures. Get your kids in the habit of doing that. At some points in the paper, it might say, give your answer to 4 decimal places, or to the nearest integer. At that point, they need to follow that instruction. Normally at one point in the paper, out of a 100-mark paper, one of the marks will be allocated to doing the correct thing there. We can't keep pinging them the whole way through every question if it's not 3 sig fig or they didn't round to an integer or whatever. Which question is going to get that mark will depend on, as we're coming up with a mark scheme, where do we feel that we can put that that's appropriate, and there's enough marks. So there's no point saying, oh, why would you ping it there, or did you ping it there, or did you not? Somewhere in there, they will get pinged if they don't do the right rounding. Some kids might get pinged, but have done it correctly everywhere else, and that just happened to be the question, so be it. So that's get them trained up. 3 significant figures, which doesn't mean 3 decimal places. I have to train my year 12s all the time about that. 3 sig figs, or as listed in the question, please. All right, sign diagrams. They need to get better at understanding. If we say show such and such as a maximum, they need to justify it in some way, either with a sign diagram or their knowledge of quadratic optimisation or using the second derivative test, whatever. Sign diagrams are a great way to do that. So it seems to have dropped out of fashion. They need to be aware that that is required. Won't always earn a mark, but it might. So get in the habit of justifying whether something's a max or a min or whatever. Anything else you wanted to add?
The only thing I'll probably add is, in a minute can you guys hear me all right? Cool. In a minute when we do go through these, often the solutions up here are super minimalistic, it's been stripped down to the most simplest sort of low bar in a way, but still mathematically okay. answer that we kind of accepted. So you'll see sometimes like a worded response is probably like better, but I've like put it in mathematical notation just to make it as simple as possible. Okay, cool.
Okay, question 1. Now, I suspect we're going to spend the majority of our time in booklet 1, because when we get to booklet 2, there'll be a few things I want to talk about, but by the last 2 or 3 questions, I'm pretty much would be saying the same things. Oh, brackets are important. Oh, they have to show working steps. So don't panic. I will try to get us finished by 7:45, because apparently we get locked out at 8 anyway, so there's no way we can be here beyond about 10 to 8. Yeah. Okay, first one, using first principles. It was a nice simple one for them to get into. They must show substitution into the formula, the x plus h bit. They must show simplification and cancelling. They must show the cancellation of h. So that idea of pulling h out as a common factor once they've sort of simplified things is incredibly useful. They tend to not go wrong if they do that. Have a line where they've got h as a common factor on the top line and 1 on h as a factor out the front or in the denominator, and then they can show they cancel. Really good idea to write a fresh copy after that, that sort of limit h tends to 0 of 2x plus h. Just this is what I'm going to be looking at when I apply my limit. Work out what the limit is. Then, so this was only 3 marks. So you sort of a mark for the early bit, a mark for the cancellation of h to get the 2x plus h, and then a mark for actually applying the limit correctly. We normally would subtract a mark if they get their notation wrong. So they must have that limit h tends to 0 all the way through until they actually apply the limit. And they have to have the equals on the left-hand side of it. It's remarkable. There are students who put the equals in the middle, showing they really don't understand what it's representing. Now, if your students occasionally, they wobble and they forget a limit h tends to 0 somewhere in the middle of it, but they've had it most of the way through, I wouldn't be pinging them a mark in your test marking, but it does have to be there at the start, and it does have to be there just before the limit is applied and disappear when it is applied. Okay, a lot of discussion.
I'm going to say a couple of things as well, just so you know, there's lots of other alternative ways that you can choose to express a first principles problem, and I work with someone who does it in a very different way to this, where he does like the change in y over change in x throughout, and then applies the limit once at the end, and that's perfectly fine. I guess the expectation, because it is a first principles question, is that there always should be a limit somewhere within the working out. If you haven't sort of used a limit at any point and you're using an alternative approach, I feel like that's not to first principles. So, and also one other thing that often gets asked in these things is they're not required to state that h is not equal to 0 in this.
Yeah, be nice to have it, but yeah. The common errors that you're going to see, so watch for, particularly if you're a new teacher, you probably notice that when we've got something like x plus h all squared, they call it x squared plus h squared. Bang, gone. And not carrying the minus through in that second term. So try and get them to be aware of those, you know. Right, part B, use of the NX to the n take 1 rule and the chain rule. Really the common errors are that they're not using their brackets properly. It's not appropriate to have the brackets around 7 plus sine x. They have to be there, otherwise it's a completely different expression there. A few students last year treated the plus as a multiplied and tried to do a sort of multi-product rule on it, but that's just a bit of an aberration. I think the key thing is be careful about use of brackets in any of these. Yep. Whoop, back.
Sorry for that. This is a 3 marks question, so is it fine for student directly write down the answer, or do they need to show?
They don't need to show any working out. If you kind of think about it, because it's a product rule.
That one.
Yeah.
Probably one for bringing the 2 out the front correctly, and one for your cos x. Something about that.
Writing this down directly, that should be fine.
Yeah, it's fine. Especially at the beginning of the paper, there's often like the marks are pretty friendly, and by the time you get to the end of the paper, the marks are pretty rough, right? There's a couple of things that are all kind of bundled up together, but yeah, you got 1 mark for the first one, and you got some marks for the product rule as a process, and mark for the second one as well. Cool.
Okay, then they had to do a quotient rule. Once again, the problems occurred if kids left their brackets off, particularly the ln brackets x to the 5th plus 1. It means a completely different thing without the brackets, so they have to get in the habit of putting the brackets. Yeah.
If sometimes kids they get into the swing of doing product rule, and so if they were to take that up to the top line, I'm assuming that you're wanting to assess quotient rule.
Unless it specifically says using the quotient rule, which I have seen in one exam somewhere along the line, then they'd get pinged. They're welcome to turn it into a product rule thing, but what we found was, which I think we suspected all along, converting to the product rule, they were much more likely to make errors and not get full marks. So discourage your kids from doing that. You can show it works, but get them comfortable with the quotient rule. It's not a hard rule to use. And you just whack it down and away you go.
The general consensus is, of course, unless an approach has been dictated that they have to do, if they've chosen to do a perfectly sound mathematical process that wasn't planned, you can't take a mark off, right? If it's mathematically sound, of course, it's okay. Yeah.
And then they had an integral. Probably, if you were going to do a mark scheme, you'd be saying there's a mark for knowing that 1 on x take 1 becomes ln, x take 3, and a mark for getting the plus 4x plus c. If they're missing a plus c, they're probably going to only be able to get 1 out of 2 marks. So the plus c is not normally allocated its own separate mark, it just becomes one where you lose it if you haven't got a plus c. So get used to saying plus c at them. I've even walked in with plus c written on my forehead before just to sort of make the point. I also love when I teach the product rule, or this could kill things, I get them, and it's plus for product. And I spit at them and they laugh and they remember it and they come back to me years later and say, oh yeah, Mrs. Miller, plus for product. So there's just a little teaching hint for you. One of the few things that works well, my kids know their product rule. Question 2. Okay, so we've got some statistics going on, probabilities going on. Part A, as long as they had words to the effect that the probabilities were not all the same. There was, 2 probabilities that weren't equal. Something like that, they got the mark. Fine. Part B, now, it was 1 mark. So they could just put down 0.222 and get that mark. We would love to have seen evidence of them adding the 4 component bits from the table. The most common error was that they found the probability x is greater than 6, so they only added 3 of those values together instead of the 4. So try and get across that idea of the difference between greater than and greater than or equal to in a discrete situation, and then try and break them out of that when they get to the normal distribution, because that's one of the common errors in one of the later questions. Part C, a joy to mark, and I hope a joy for the kids. They just had to know which formula to use. Part D, okay, so we've had to come up with a confidence interval. Confidence intervals are very commonly worth 2 marks. One of the marks will be for getting the end values correct. One of the marks will be for the notation in the middle. You must be kidding me. Why would you give a whole mark just for writing mu in the middle? And it could be mu, it didn't have to have mu sub x, but it can't be x bar. It can't be p, it can't be p hat. You'd be amazed how many kids put those weird things in. Oh, I'm doing a confidence interval, I'll just put that down. The other really silly thing that they do is we left a tiny bit of space here, and it was 2 marks, and they go and put it they do it all manually using the formula. And it takes forever, and they might make a mistake. Get them really comfortable with just doing it on their calculator. It's amazing how often you'll think you told them that in class, and then you go and check, and you find, oh no, I don't know how to do that on my graphic calculator, like the lesson before the test on it. Here, and, oh, that's easy, great. So get them doing it on their graphic calculator. Does this suggest further investigation should be undertaken? Yes. It's not, oh, the claim is supported or not. They're just reading from their notes. It's not about a claim here. It's, do they need to do further investigation or not? Yes, That gets them 1 mark. Then they have to justify their answer with something common sense. So saying the confidence interval is all above 3.44 or 3.44 is all below the lowest limit of the confidence interval, something like that, fine, gets you there. Just saying that 3.441 was outside the confidence interval didn't earn the 2nd mark. It's too vague. They haven't sort of understood, they've sort of gone, oh yeah. So they need to be specific when if it's outside, say it's above or below. And yeah, we talked about them just saying, talking about the claim.
Just one thing with that as well, like that's an example of like the stripped down version of the solution. Like you'd want to say, like, you'd encourage the use of words like entirely above and things like that. Of course, it can be defined the other way around in relationship to where, as the confidence interval is above that value, you can define it the other way in terms of the value as well. I just got to think about the reverse way of
Value
explaining.
would be below the
Yeah,
confidence interval.
that kind of stuff as well. But I always think like this microphone here is not above this, so like it's above it when it's entirely above it. So you have to accept above in just that one word anyway. You know what I mean? But I wouldn't personally use it normally.
Is that okay? All right, question 3. Okay, short little simple question. They had to generate sign diagrams for f dashed and f double dashed from the given curve. So we were looking for, in each of the sign diagrams, that they've got the correct critical values listed on their axis and no extras thrown in. So in the sign diagram for f dashed, you can't have 1, 2, 3 and 4, or they'll lose that mark for the numbers. It should have been 1, 3 and 4. Ideally, we wanted a dashed line at 4. And they had to have their signs right. In the second one, they had to have just the 2 and 4, and they had to have their signs right, and they should have had a dashed line at 4. We do try to be a little bit kind that if they had missed a dashed line and they'd had a 4 there, we would only ping them 1 mark out of the 4 that were on offer for this part of the question. We try to not double ping people for the same error every time. That's a general principle. So, yep, that should cover off on that. Now,
Can I say one thing?
Yeah.
Just one thing I've noticed from lots of responses I've seen is like, encourage your students to be careful about putting extra numbers on the sign diagram. So like not this problem, it didn't come up in this problem because you're not substituting in any values and assigning a sign, but you see lots of students that like say substitute in say 2, and when they substitute in 2, they then write it on the sign diagram, which affects the sign diagram. They put like a negative either side of the 2. That's now unfortunately made that sign diagram incorrect at that point. So just watch for it, and I think teachers that have been doing it a while know about it, but new teachers, just be careful the way you're teaching sign diagrams to ensure you're not putting extra points on.
yeah. They're particularly keen. In this case, it didn't crop up because we had a nice wall at 0 for them, but they love to put a 0 in just to sort of set the scene. And if it's not a critical value, it shouldn't be there. So then they had to have a go at drawing f dashed of x from that. Now, this has cropped up often, and we want you to let students know that the sign diagrams that we just got them to do are there to help them with this, but we can't mark their curve based on their sign diagram. If they've made a mistake there, how do we know whether they're graphing from their sign diagrams or from the original? And it becomes a horrible mishmash. So we have decided that we will mark their f' curve based on the actual function. They either get it right or they don't. So what are we looking for in that curve? We're particularly in this case looking for it cutting through at 1 and 3 and having a minimum at 2. So it's about that shape. Oh, is that me? I'm sorry.
It's because there's meant to be a cover on it.
The shape and, so intersects the minimum. There needs to be an asymptote at 4 with the right shape over on the right hand. So it should be asymptotic to the x-axis and that vertical asymptote. They might lose a mark if they suddenly threw in a few kinks and bells and whistles, so any points of inflection, etc., would cost them a mark.
One thing that's worth noting, the thing that got noticed a lot weirdly is the graph would go up to 4 and then nothing would be on the other side. I'm not quite sure exactly what happened, but that seems to be a real common thing with it. The other really important thing is that it can't come down and cut through the axes again after 4 either, otherwise I'd get pinged a mark.
So to get the full 3 marks, they had to really understand what was going on with that right-hand side of the graph, not just the first bit. That, yeah, if they've seen a lot of sort of x-cubed type graphs, they know that that will transfer into a parabola. So they're pretty comfortable with that left-hand side, and then the right-hand side, they're, ooh, no. So they could still get 2 out of 3 for that, which is appropriate. Question 4?
Sorry, I've got 2 computers. Sorry if I don't scroll. I'm doing 2 computers at the same time.
You're almost a female, multitasking there, it's just wonderful. Okay, the fat content in Ted's oat milk, pretty straightforward, at least 2.8 grams of fat. They could just write the 0.388 there and get the mark. They don't have to have a probability statement. For new teachers and old teachers, I'm old, experienced teachers, it's a better way to say it, I strongly encourage you to get the kids to write the distribution that they're working with in any statistics probability question, write out what the distribution is, and write a probability statement to go with it. For these few, they're a 1 mark question, so it didn't matter, but sometimes there's 2 marks allocated for one of these, and if they've put the right distribution down and the right probability statement, we know that they know what's going on. They may have fumble-fingered their calculator, so they lose the 2nd mark. Or they've put the wrong distribution down for some reason, or the wrong probability statement, but because they've put the distribution and the probability statement there, as markers we can actually use our calculators and check, did they use their calculator correctly? Does their figure match what they did? And they can still get 1 mark out of 2. If they put the wrong answer down and they've got nothing to support it, they're going to get 0 out of 2. So it's a good habit.
I think the only one that sort of sometimes doesn't have that is like, there's normally a separate set of solutions with the good old mean and standard deviation the wrong way around, and you can spot that one coming in the first question and then take 1 mark off and not penalise them for the rest of the question. Because again, like, what mistake has that student really made? They've only really made 1 mistake, so there's no point smashing marks off them the whole way through a question. That's 1 mistake.
So for those of you new to teaching this year, when you get to the statistics part and you get to doing these distributions on, say, I use a Casio, lots of people have Casio, kids get trapped because we always talk about the mean and then the standard deviation, and yet on the Casio, the first thing you have to put in the list is the standard deviation and then the mean. So that's what we mean by we sort of already have had a look at what would the answer be if the kids have put it in the wrong way round. Then we'll dock them a mark the first time, but we can follow through from that and just check all of their other ones based on having those the wrong way round. So just warn them, be aware. It's in the other order on a Casio. I'm not sure what it's like for other models.
To you guys, it's the right way around. I've tried sending angry sounding emails to Casio and got nowhere, but I have tried because it's stupid. Cool.
Okay, so then we've got between 1 and 3 grams of fat, straight answer. Packs of 6 cartons, so we've got sampling distributions now. Explain why S6 can be modelled by a normal distribution. Really, the only answer is that the underlying distribution is normal. Central limit theorem therefore kicks in, which says if the underlying distribution is normal, it doesn't matter what sample size you have. It's no good saying, oh, because 6 is sufficiently large, because we wouldn't normally know. Normally 6 would be a bit dodgy, you would think. Just saying, oh, because of the central limit theorem, not enough. No, that's just whacking something down from your notes. So they had to at least have in their notes or in their heads that we started with a normal distribution, so this is fine. Right. The next bit was a show that, so they needed to actually have the 6 by 2.7 and the root 6 by 0.35 or something equivalent to that. They needed to show, not just write the answer down again, obviously.
Just for any new teachers as well, the show's just used there to allow the buyback into the question later on. So if a student can't get those answers are there that allows them another re-entry point into the question at a later date. Yeah, so just encourage your students and try to use those words in your test throughout the year. That soon as there's a show there, the onus is on the student to do the extra steps to get those numbers. Because there's no mark for writing 16.2 because that's given in the question.
And of course, this gets used in the very next part where they have to find a probability, and that should be the mean and the standard deviation that are going into it. Now, and this is where it's meant to be the probability that S6 is less than 18, and we had students that were finding the probability S6 is less than or equal to 17, because that's the next number down. So they've got that discrete headset on. So be aware, you actually need to say that several times in your teaching, that, hey, there is a difference between discrete and normal. Make sure you're doing the right jump at the right time. Right, then they had to do an inverse norm. So it was a left tail question. Common errors would have used the right tail and get a different number. Now, if they used the right tail and got the wrong answer here, we followed that through to the follow-on part D. This is only a 1 mark question. Sometimes in the past, inverse norm questions were up to 3 marks, and they had to have a probability statement. They had to say that they were using inverse norm. They had to say which tail they were using, and then they would come out with what the value is, and often then they would interpret that in the context of the question, and they'd get 3 marks. This was just something that we wanted them to be able to use in part D. This brings up the use of calculator notation in their answers. There's Casio's, there's Texas, and there's Hewlett-Packard's that they can use. They all have slightly different things, and kids start to think, oh, I will put inverse norm bracket, blah, comma, blah, comma, blah, comma, blah. This is what I would input in my calculator. Markers are not expected to understand how to use all different models of calculator, so calculator notation is not marked. I mean, they can write it down there, but it's going to cost them time. But there's nothing wrong with them saying, oh, K will be inverse norm of 0.99. That's not about all the other things that you would put on your calculator. It's just saying, I'm doing an inverse norm calculation. That's all right. That's not calculator notation. That's just the logic of what's going on. So be aware, calculator notation won't cut the mustard. If they've got the wrong distribution, that's not going to be, we're not allowed to look at that and say, oh, I see, they were using the mean and the wrong mean and standard deviation. I can follow through. We're meant to just ignore it. Then we have part D, where they needed to use that inverse norm, that 18 became an 18, take the mean over the standard deviation. So 1 mark really for that second line. I would say that's the logic of understanding that question, which was a little bit on the tricky side. And then 1 mark for manipulation, I would think. Common errors here were some kids using trial and error. I think the trial and error came in, and then it blossomed to a few years ago. There were about 3 or 4 questions in the exam where you could have used trial and error to do stuff. There's nothing wrong with trial and error. I mean, it's used in the real world a bit, but that's not what we really want to test. We'd like to know they know how to use it appropriately, but that wasn't, I think we're trying to move away from that. So the wording in this to say trial and error is not acceptable was using your answer to part C. So if they do not use part C, they did not use that 2.33 in their working, then they weren't going to get full marks. Probably if they used trial and error to get to the right answer, they might have got 1 out of 2, but they can't get full marks. Okay. Question 5. Oh, beautiful. 5A, state the nature of the stationary point. Local maximum, we'd accept maximum because it's a domain, restricted domain anyway. Global maximum, local maximum or maximum, gets the mark. Easy, I would assume, very well done. Determine the derivative, 2 marks, so 1 for, the derivative of cos being negative sign, and 1 for your chain rule. Brackets, essential. We can't have the brackets missing from around the 1/5 x squared take 1. Hence, so you've got to use that, or whatever they came up with. Using an algebraic approach, determine the exact value of A. So there's 3 key words in that. The hence means have a look at what you just did. The algebraic approach and the large amount of area and 3 marks tells you you're going to have to show some working steps here. And determine the exact value of A means don't just spit out a decimal answer. Don't just go to solve n and plop something down. Solving is full of pitfalls, so I would discourage students from thinking about it. Learn how to do the algebra. All right, so we wanted to set the derivative to 0. Now, we don't want them to just be putting what's on their sheet, f dash of x equals 0. Well, that's fine, but really, you've got to show you understand what that means in this question, which would be minus 2/5 x. Whatever their derivative was from over the page has to be set equal to 0. Okay, so we've shown some good understanding there. Then we want to show, do I know what the solutions are? 0 or sign has to be 0, which becomes the 0 plus multiples of pi. Now, if they made errors and they had cos, well, you know, markers have to follow that through, but they're looking for clear evidence of them getting rid of the trig function to come up with solutions. Not necessarily the plus pi k. I think with only 3 marks would probably be a bit forgiving, but you should be encouraging students to think there are an infinite number of answers here. We did have quite a restricted domain and a graph for them to look at, so probably in this situation it's not so desperate for them to be thinking there are infinite solutions and break it down. However, once you get down to solving, really they should have come up with plus or minus as options. They needed to get rid of the negative option, because we're looking at a particular domain here.
I think we also, in this case, we forgave, if they didn't, like for this one in particular, because the domain, I think we forgave, it says that A is between 0 and pi, not inclusive. So if they didn't include the 0, we accepted that as being all right in this case.
And also if they said just root 5, they didn't consider plus or minus and then lose it and become just the plus. With only 3 marks and with plenty of information and visual information there, it was okay. They had enough to do to know they had to set their derivative to 0, know how to get a solution for a sign of something, and then manipulate that to an exact answer. So there's a lot in there.
Again, like you want to encourage your students to always do the plus or minus, because you can imagine this question reflected about the y-axis is probably a slightly stronger question retrospectively, isn't it? Where like you'd get your plus or minus and then you'd have to take the negative of it. So I just encourage your students to keep doing the plus or minus, but it becomes a difficult thing in the marking process to work out if a student's actually considered the plus or minus or not. And in a case like that, unfortunately, you have to give them benefit of the doubt. Yeah.
Not unfortunately, we're just nice people. Okay. The interval for when it's increasing. Now, Dan's has got like less than or equal to there. We also accept 0 is less than x is less than root 5, because we're not on about strictly increasing and decreasing at year 12 level. And the final answer, any kid could get into that and see that it was decreasing most rapidly at pi. So they could just write pi.
And the other thing, of course, is follow-through marks in all those, or in the part 3 as well. And even if they couldn't get A, if they wrote from 0 up to A inclusive or exclusive of the endpoints, they still got the mark as well. Yep. Cool. Because again, what we're assessing whether they have an understanding of the problem, and in that case they definitely do, so they'd get the mark.
Okay, question 6, very sort of COVID related. Testing medical samples arriving at a lab. It was a show that the derivative is. So students who did well generally converted the t root t into t to the 3 on 2. They actually showed they'd converted square roots into powers, because then they could show that sort of second line with lots of individual elements that would then multiply through to give the answer they were after. So they can't just repeat the answer that we wanted. They had to have those individual elements shown. Good use of brackets was important as well. Yeah, that would do. Hence, so using that given derivative, using an algebraic approach, show that the rate at which they arrive is maximised. So a sign diagram is needed here to show there's a maximum at that point. So they had to set the derivative to 0. They had to factorise to solve. If they divided through by t, root t, whatever, they actually lost one of the solutions. T equals 0 is one of the solutions. So encourage them not to do division when they're doing these problems, but to use factorisation and the null factor law, so they don't lose any possibilities. They had to come up with 2 solutions. Ideally, they'd say that the e to the bit couldn't be one of the solutions, but I think if they came up with the 0 and the 5/3, that's good. They'd already been given the 5/3, so that was sort of not worth a mark. And then the sign diagram to show it was a maximum at 5/3, not a minimum, or a point of inflection.
Yeah, we'll keep saying it. I'm sure you experienced teachers keep saying it. Sign diagrams, like anytime things are asked if they're a maximum or minimum or of those type of questions, ensure that students are drawing sign diagrams. Yeah, it's just something that's seemingly a bit weaker.
Okay, now the course outline now includes non-monotonic monotonic functions. What that means is we used to just have, it's increasing, so the upper estimate will always be from the right-hand edge. Or it's different, the lower estimate will always be from the left-hand edge. They just sort of got into a pattern of doing stuff. Now, here's an example where for the first rectangle, the high point, the height of the rectangle, doesn't come from the left or right-hand edge. Now, because it was the first time that this has been in the course in this way, it was determined that they'd actually draw it for them, so it sort of gives them an in, but we can't guarantee that in future. So try and include a little bit of one or two of these. They won't be in your textbooks, so come up with one or two of these to show your kids, what do you do if it's not at the edges? Excuse me. Okay, so the value of the overestimate, they have to have a structure of the widths are 3 and the heights are coming from the appropriate point, so 6 and 3, and that 5/3 from the previous part. And then they have to come up with an answer.
I would say this was probably really poorly done, like out of a lot of the questions we came across. Like, I feel like students were just putting stuff on their notes and taking stuff straight off their notes. Like, I've got more work things of lots of my things, and you can see all the different versions of things that came up with different values for, particularly just that first rectangle, like all the different values that people like subbed in order to get the height of that rectangle. The whole point of the lead-in of this question was to give them the x coordinate that the height of that rectangle comes from, so that they would get a more intuitive understanding of what's happening with it. But clearly students didn't follow that and as well as we would have liked. So, yeah.
Okay, and then they had to calculate the integral that went with it. It was only 1 mark, so if they just whacked down the answer and it was right, they got the mark. It did say to the nearest integer, so potentially they might have lost that mark if they didn't round it to the nearest integer. Probably unlikely when it's only 1 mark. We'd be wanting to reward the skill, but it did say to the nearest integer, and that was a common error that people didn't round. So get them doing what the question asks. And then we've got the rate at which they're processing the samples is now on the graph. And they had to explain why the number of items in the queue is decreasing in the early hours. And this is where, now Dan has got, because P of T, if you could scroll just a little, because P of T is greater than M of T at that point, that's a beautiful, succinct way of doing it mathematically, but mostly kids will have done that with words to that effect. So that's fine, they get that processing, more are being processed than are arriving at that time, that's fine. Then they had to come up with an integral to represent that. Oh, no, hang on, it was a bit different. When it's increasing, so they had to come up with this. Now, I'm not going to go into the why that's the right answer or not. You can think that one through. Once again, we're looking for the limits of the integral to be correct and for them to have m take p, not p take m. So that's the sort of thing that we're pushing for. And over the page, they then had to evaluate that, once again, to the nearest integer, if possible. Now, some of them, if they, in the previous one, had done p take m instead of m take p, their integral will have spat out a negative answer. So they might have earned that mark, but it doesn't make sense when you're doing this, so they needed to make a comment that clearly that was incorrect. And they couldn't just suddenly turn what should have been a negative into a positive either. That's just fudging, so they'd lose a mark if they didn't comment. Number of samples in the queue at 5, they had to do the integral for the whole time period, get the right thing on the top, m take p, and they had to account for the 600 samples that they were told was already in the queue. So just a nice little one where they had to pull a whole lot together and get it the right way around. That's just one way they could do it. I think there were a number of different ways that they sort of achieved the same result, but they had to include that 600.
Lots of other really clever ways you can get there without really even doing much work as well.
Okay, book 2. Oh, sorry. So start to get similar comments here, so this is why I feel like we'll get through this a bit quicker. I know we've only got about 12 minutes left, and that's fine. All right, show that the derivative. So once again, there has to be some evidence. You can't just whack it down. We have to have the elements shown. Using an algebraic approach, determine the y-coordinate of the stationary point. They needed to show evidence again. They couldn't, otherwise we didn't know whether they just put that on their calculator and did a G-solve, min, because they can see it's a min. So, students found the x-coordinate, but then didn't plug it in to show what the y-coordinate would be algebraically. So, if it says find the coordinates, we're expecting x and y, train them in that. Right. Now, they had to come up with a conjecture, so they had to fill a table. If everything was going nicely, they had these answers. Generally, it's a good idea when they're doing this sort of thing to put things as fractions. You tend to see patterns better as fractions. And comes out with a nice, easy -1 on k for the y-coordinate. Same sort of problems happened. Kids were just putting down the x coordinates and trying to come up with a conjecture for that, which was just too simplistic. Sometimes we tell them, if you really can't solve something and you can't see another way in, make something up that seems relevant so that you can then go on and show that you've got the other skills. Well, that's not a bad thing. But here, to just randomly put some numbers in that happen to follow a pattern, perhaps from the conjecture that they had written on their help notes, we weren't going to allow that this time. So,
yeah, if you want to kind of know, we felt that lots of students, will make the mistake where you find the x-coordinate and forget to find the y-coordinate. So if a student did that, would accept the conjecture of the x-coordinate of A through to the x equals down here. But I feel like students maybe created the hack of they just write 1, 2, 3, 4, and then they just write k down here. And so I had to draw the line somewhere about what we award the mark for it. So we ended up saying, unless it's either the x-coordinates or the y-coordinates, they're not going to get a mark for the conjecture as well.
Fortunately, the x-coordinate wasn't 1, 2, 3, and 4, which would be too simplistic. It was like a 1 on k, positive 1 on k for the x-coordinate. So it still sort of had the same level of complexity to come up with a conjecture. Okay, then they had to prove or disprove it. You teachers, please make it clear, and everyone else would know, make it clear to your students that they can't just do another value. They can't just go, okay, what happens if x equals 5? Oh, look, that matched my conjecture, yay. Get 0 marks, because we've already awarded marks for all of that process. They have to do it in a general form. Students who did well at this knew their log laws well. Often the idea of saying ln x plus ln k is the same as ln xk made it flow easily, but there were lots of different ways that they manipulated things and got down to x equals 1 on k. Then, common error, they didn't go ahead and find what the y value was when x is 1 on k. Or they got to this line, they plugged it in, and then miraculously it was -1 on k. There had to be evidence of them particularly coping with this ln of 1 on k and using their log rules to bring that minus out the front so they'd cancel.
Yeah, there's heaps of different ways you can do that, by the way. You can bring it together really early in the process, and it's probably a lot simpler, but yeah, there had to be evidence of process.
Okay, question 8, choc precots. I said that pretty well, I can never say that.
Second time better.
Exactly 6 chocolates, probability x equals 6.0205, ideally to 3 significant figures. 0.02 with no other evidence, I have a feeling that might not be enough there. We try to be forgiving if we feel that there was no other way they could get the answer, we'll try and give them the mark. If there were other possibilities that would have given a similar answer when rounded, then we have to be a bit tougher. More than 20 choc precots. writing that that's the same as probability x is greater than or equal to 21 is a good idea. That tended to help kids get the right answer, because obviously heaps of kids actually found the probability x is greater than or equal to 20. They added in that extra.
And that's a classic example, by the way, of like a final answer only kind of question. So they don't need to show any working out to some of the things that was getting discussed over here to get both those marks, right? But imagine they only do the probability x is greater than 20 or greater than equal to 20, they'll lose 1 out of the 2 marks for that. Do you get what I mean? So like they don't have to show the conversion of it, but it's just, like Linda said, it's best to show the conversion.
Then they had to sketch graphs. So the general idea behind sketching graphs, make sure your kids know how to use trace on their calculators if they're using a Casio. They can quickly pop a few dots on their graph in the space of a few seconds. Always GSolve min, get your mins or your maximums accurate. Get your X or Y intercepts accurate from your calculator so that then the rest of the curve should flow fairly well. And we try to be pretty forgiving. If you wobble a bit or you've got a really sort of bit of a pointy minimum there, Dan, like it happens. But what the marking team tend to do is, as long as their minimum was somewhere within that square, they get the mark. As long as this point here was somewhere sort of within a half square radius, they get the mark. So we try and give them sort of a bit of an error bound to be kind, but they needed to have the minimum in approximately the right spot. They needed to have the endpoints in approximately the right spot, and they needed to have an inflection point on the right-hand side, but no inflection point on the left. And no extras.
If you're wondering why it's highlighted, it just looks like it's a coloured in dot on your sheet, so I just highlighted to say it's technically an empty dot. It weren't penalising if it was a filled in dot or an open dot, sorry, just so you know.
So in part C, they had to do a bit of manipulation. Now, they couldn't just read it off their graph. We needed this to be pretty accurate. So 2.01 and 6.15. Lots of students found one answer, but forgot about the second one. You encourage them to use their graphic calculator for that sort of thing. Particularly, they shouldn't be reading things off a graph that they have drawn. Once again, a minimum probability using their graphic calculator. Don't read it off the graph. Then they had to find p hat. We had another confidence interval, so we were looking for the end points being correct and P being in the middle. One thing for new teachers, just be aware, like for X bar or for P hat, that always sits exactly in the middle of the interval. It might be something you hadn't sort of considered before when you get to it, but because the interval is built around P hat plus some figures and P hat minus those figures, it's always in the middle. And it's really good to try and get kids to be aware of that that's the centre point of your confidence interval. Might help them not be making comments about P hat when they should be commenting on P at times. Then we had an interpretation of claims. So once again, reading things off their help notes is problematic. Here they had to decide, can it be concluded that the manager's claim is false? It's not about the claim. Can it be concluded it's false? No, because the 0.0781 from the previous page lies within the interval. So they had to understand that the claim being referred to was 0.0781 and not their p hat value of 0.075, because of course that lies in the interval. And they had to have a clear explanation. Okay, so we're running a bit low on time. I'm not actually going to discuss part 4 because you need to take your time and get your head around that. And it's not something that's likely to ever be tested in that way again. It was one of those discerning questions because we're trying to split the whole cohort from merits down to should they even pass. So that was one of those really, A+ type parts that only a few kids got.
You're welcome to ask me a question about it afterwards, of course,
Yeah.
if you want as well.
Question 9, show that. Once again, we need to see evidence. Successful students converted the square root into a power of a half before they tackled this, and that tended to give them a really easy way of showing the intermediate step. They had to show that the normal has such and such an equation. So we needed to see them generate the point of contact. We needed to see them come up with the slope. We needed them to then generate an equation of the normal. That is one way that you can come up with the equation of the normal. There are 3 other very common ways of doing it that would all earn them the same marks. So once again, if you're not sure whether the way that you think you're teaching it is acceptable, hopefully, I don't know, Massa might be able to put our email address up on the website or something. We might ask them to do that, Dan, so that you can email us if you're not sure.
But again, by the way, just to reiterate it, I know of 4 main ways of finding that equation of the line, and there's solutions for each of those different approaches for that question, and also in part C, part 1. So they're extensive. Like, if a student's doing a correct approach, it's unfair of them to do it like the way that was expected. As long as it's a consistent mathematical approach, then it's perfectly fine. Yep.
Part C, it was a show that, so once again, we were looking for clear working, clear cancellation of the square root factor and so on. So repeating what I've already said, so I won't say it again. And then they had to find, interesting, the derivative of x with respect to a. And lots of kids cope with that quite well. The ones that didn't sometimes set x equal to 0. And they needed to show it was a maximum. So they needed to have a sign diagram or a second derivative test, or they could have recognised it was a quadratic and used that sort of x equals minus b on 2a to establish that that was a maximum. And the last question, probabilities from integrals, length of surface life of an item. Part 1, integral from 0 to 1.5, so you've got the solutions there. The common error was, instead of doing an integral from 0 to 1.5, they just said, oh, I'll just find p of 1.5. They weren't understanding the difference. In the second part, yeah?
Sorry, yeah, they were just literally subbing 1.5, and the numbers ended up looking really similar. It was very annoying.
In the second part 2, they had to reference the fact that the 0.430 that they'd got from above, its relationship to 0.5, that it was less than 0.5, and therefore that 1.5 was less than what the mean had to be. So words to that effect, or some very nicely just written mathematics. They couldn't just use their graphic calculator and say, the mean is here, and compare that. They had to use their answer from A part 1, because that's what the question said, not just my opinion. And then we had some sloppy bracketing here, and things where the k suddenly went inside the x on 2 brackets and the powers were all over the place. So careful use of bracketing, and they got there. And we particularly wanted to see the 2 negatives showing that would then become a positive. And our final part of the paper, key steps, they had to substitute at some point that the m equals 1.5, the median was 1.5, and set it equal to 0.5, as in the thing, whereas some kids set it equal to 1.5 for some reason. They had to use B part 1, the line above, to substitute in for their integral. Lots of kids got this far. They needed to show clearly that when you've got substituted in 0, you get e to the 0, which becomes 1, and then work with that. And the key thing in the last couple of marks were about them having to take logs of both sides. And you can't do that until you're sure that they're positive values. So they needed to be rearranging things until they had e to the something equals 0.5, not negative e to the something equals negative 0.5, and now I'll take the logs of it, because you can't have a log of negative 0.5. So encourage them. It's got to be positive. They did some manipulation from that, and then they had to, once again, get things to the point where they were positive, and you could take the log of a log. Blows your mind, but lots of kids got there.
Surprised. And it didn't matter what log base they used, of course, as well. They can choose whatever log base they want to choose, really. I just happened to do it with ln.
So like I say, a really good idea to print off the assessment advice that's on the SACE website, because a lot of this is on there as well. We'll try and get Massa to put our emails up there if you would like to think of some other questions. But Massa are probably, and the school are probably keen for us to depart now before the alarms all shut down. So thank you for coming in at the end of a long week, long day.
Yeah, thank you, Linda.
Ooh.